Hello, this video is on the subject of fires and explosions. This video will cover the material for the fires and explosions part of the West Virginia Mine Foreman test. The format for the video is question and answer. This video will also reference the question and answer to the West Virginia Office of Miner Self-Safety and Training Mine Foreman Study Guide, and that would be the 2019 edition. And these questions are in the fires and explosions part of the study guide. Question 1, what are the principal causes of mine fires? And the answer is open lights, smoking, electrical sparks, heating of electrical equipment, ignition of gas, and spontaneous combustion. So I think everything there is pretty clear, and we can all understand how they could cause a mine fire. The one there, the open lights, is something that I didn't understand for a long time. I've always heard open lights in mining classes, never quite understood that. And finally, an electrician in a class told me one time an open light is a light bulb that is not guarded. So if you have a light bulb that could be broke because they don't have guarding, that would be considered an open light. And I think we should avoid those in the mines. Question 2, what methods have been used to extinguish mine fires? And the answer is chemicals, rock dust, sand, enclosing the affected area with seals, flooding the affected areas, and foam. So all those items there could be used to extinguish a fire. Number 3, when can rock dust be used to extinguish a mine fire? And the answer is when the fire can be approached near enough so that the rock dust can be directed upon the burning material. So if you could get close enough to the fire that you could spread the dust on the fire, then that would be an effective tool to extinguish the fire. Question 4, what advantage does rock dust have over the use of water in extinguishing a mine fire? And the answer is the rock dust can be carried by the air current deposited on the fire. It also eliminates the formation of steam and water gas and protects the roof from disintegration caused by steam and water. So that's quite a long answer, but the rock dust can be carried upon the air current deposited upon the fire. I think that would be a very unscientific method of getting the fire extinguished because you couldn't really control that. But also I think that we can all realize that rock dust would be much better than water because water is just going to make a mess. It's going to make everything wet, muddy, and rock dust would be a much better tool if it could be used to extinguish the fire. Question 5, safest and most effective means of controlling a serious mine fire, and that would be by sealing. So if we have a big fire, a fire that's getting out of control, you can no longer want to get close enough to it to spray water or rock dust on it, then the safest way to control that would be by sealing. Question 6, when should a mine fire be sealed? And the answer is whenever it is not reasonably safe to employ direct methods of fighting the fire. And that's just what I just said. When it's no longer safe to get close enough to that fire to spray water on it or throw rock dust on it, then you should seal it at that point. Question 7, what's the objective or reason to seal a mine fire? And the answer to that is to cut off the supply of oxygen. So if we cut off the supply of oxygen, we're no longer adding new air to it, which has oxygen in it. The fire will eventually consume the oxygen and it will go out when there's not enough oxygen there to support the fire. Question 8, what are the principal hazards in sealing mine fires? So the answer to that is explosive and asphyxiating gases. So if we were sealing a mine fire, we would have to worry about methane, a methane gas explosion, and also the asphyxiating gas, and what comes to mind there to me is carbon monoxide. Question 9, what changes occur in the atmosphere behind the seals when a fire is sealed? And the answer is carbon dioxide and carbon monoxide increase. Oxygen is depleted and explosive gases may accumulate. So when we're no longer adding air to the area, and we do have a fire going, carbon dioxide and carbon monoxide will increase. The fire will create that. The oxygen is depleted because the fire is is consuming the oxygen, and explosive gases may accumulate. So if you have a gassy coal seam, you could have methane gas entering that area, and since we're not adding any new air to it to dilute it, then methane gas levels could increase. 10. What's the first thing to do after discovering a mine fire? And the answer to that is the first thing that should be done when a fire is discovered is to withdraw all employees except those engaged in fighting the fire. Very important when you have a fire at a coal mine, no matter how small it is, if it's inside the mine, we need to get everyone out of that coal mine except the people that stay in for the sole purpose of fighting the fire. Question 11, what's the principal danger or the biggest danger while fires are being sealed? And the answer to that is the danger of a gas explosion. So if we're building seals, we may have a mine rescue team doing that under apparatus, so they're protected from the carbon monoxide, but they would not be protected from a methane gas explosion. So that would be the biggest danger when we were building seals is a methane gas explosion. Question 12, what type of seal should be erected first? And that's temporary seals. So that's something we're going to put up quickly to block the air from the area where the fire is. And, the temporary seal could be a Kennedy stopping. It could even be a curtain. If you could put a curtain up really tight against the ribs, top and bottom, that blocks the air from going into that area, that would work. And temporary seals should be built first. And hopefully if you build the temporary seals, exclude the oxygen from the area the fire could go out. Question 13, after seals have been erected, there is a danger of an explosion while the oxygen content remains above what amount? And that's 12%. If we have 12% or more of oxygen, we can have a methane gas explosion. 14, what are the essential requirements of permanent fire seals? And the answer is they should be as airtight as possible. So if the fire seals leak, the fire may never go out. So they should be airtight and airtight as possible. 15, how can permanent fire seals be made relatively airtight? And the answer is that by hitching them into the floor, roof, and ribs and coating the seals. So I have a picture here, and I don't know how good a picture it is, but trying to represent what hitching means. And hitching means that you would cut a channel into the bottom, ribs, and the top, and the seal that you built would extend into the top, ribs, and bottom. Then you would fill that material in maybe with concrete or some kind of B-bond or something to make it tight there, and then we would put some coating material on the seal to make it airtight. I've been told that this question's on the test, and it's they say it's kind of funny the way they ask it. So make sure you understand that hitching does mean that the seal extends out into the ribs, up into the top, and down into the bottom. And the purpose of that is to make it strong and make it airtight as possible. Question 16, what should be placed in all fire seals? And the answer is permanent fire seals should be provided with pipes so air samples can be collected and excessive internal pressure can be bled. So every seal has to have a gas sample pipe, and that would be on top of the seal, and it would extend from in front of the seal to midway back into the first intersection behind the seals. That's usually a 1/4 inch or 1/2 inch PVC pipe. And it's going to be 12 inches from the top, I think. You'll have a plan for that, but it's probably going to be 12 inches from the top. So someone could access the front of that seal and tell what the gas condition is behind the seals. And also, excessive internal pressure can be bled. That is a water trap, so that when water builds up behind the seals, it will flow out through the water trap so water pressure doesn't cause the seals to be pushed out. Question 17, how can excessive internal pressure, and that is water pressure, be relieved from the sealed area without permitting air to enter? And the answer is bleeding the water from the area with a water trap. And I have a picture here, so the water builds up behind the seals and then will flow out the water trap so water does not build up and push the seal out. So you can see it's just a U-shaped pipe here, and the pipe is extending out of the seal. As water builds up, it will flow out, and this should be placed in the seal at the lowest elevation. 18. What would a continued high oxygen content in the sealed fire area indicate? And the answer is that there is leakage of air into the sealed area. So if it is sealed up and it's not leaking, as the fire burns, the oxygen level will trend downward. It will keep going down, and the rate that it goes down will depend on how big the area is, how intense the fire is. But if the oxygen doesn't trend downward, if it never goes down, that means that there's air leaking into the sealed area. Question 19. What would a fluctuating high carbon monoxide concentration in a sealed fire area indicate? So the carbon monoxide just keeps going up and down. It don't stabilize, it doesn't go down, and it just bounces around different numbers. That would mean that there's a leakage of air into the sealed area, keeping the fire active. So if you have carbon monoxide behind the seals, you have an active fire. Question 20. How would an air analysis of the air behind the seals indicate the fire was extinguished? And the answer is that by low oxygen and the absence of carbon monoxide. So when you seal an area up and you have a fire behind it, you build the fire seals, it's going to burn until it consumes enough oxygen that the fire would go out. And I think that's about 15 or 16%. And also when the fire goes out, there would be no more carbon monoxide. So that would indicate an air sample that has low oxygen and no carbon monoxide would indicate that that fire has went out. 21. What are the two most dangerous gases encountered in a mine fire? And the answer to that is carbon monoxide and methane. Carbon monoxide is an extremely poisonous gas, harmful to people, and methane could cause a methane gas explosion. 22. What combustible and dangerous gas may be formed by the application of water to a mine fire? And the answer to that is water gas. And water gas is a combination of carbon monoxide and hydrogen. I have a picture here. So I have a fire, and I'm spraying water on it. And water is H2O. That's the chemical symbol, or the composition of water is hydrogen and oxygen. So water is sprayed on a fire. The heat from the fire converts the water to steam, and the fire burns the oxygen away and leaves hydrogen. And hydrogen is explosive from 4.1 to 74%. Therefore, you can have an explosion. So imagine that you're spraying water on a fire, and that causes a hydrogen gas explosion. I think that could happen. I've talked to some mine rescue people that they've kind of told me that it's highly unlikely that you would have a fire at a mine that would be hot enough to create that conversion from water to steam to an explosion. So hopefully you never encounter that, but that question could be on the test. So what explosive gas could be created by spraying water on a fire, and that would be hydrogen. 23. How shall a mine fire be approached? And the answer to that is cautiously from the intake side by a competent person. If we have a fire, we always want to stay on the intake side to avoid carbon monoxide. Question 24. What amount of time is arbitrarily set to wait after temporary seals are built before rescue teams are permitted to return to seals for investigation? And the answer to that is 72 hours. And arbitrarily means based on a random choice or personal whim, rather than any reason or system. So when we say arbitrarily and we say 72 hours, that's just a number that they choose. So what we would do, we would build temporary seals as we were exiting the mine. And then after 72 hours, the mine rescue team could enter that area to see the condition of the fire. And hopefully by that time it's went out. 25, how can it be determined when a sealed fire area can be opened? And the answers are samples of air should be taken from the sealed area and chemically analyzed to determine when a sealed fire area should be opened. And what you would be looking for is low oxygen and the absence of carbon monoxide. Question 26, what does the presence of carbon monoxide in a sealed fire area indicate? And the answer is carbon monoxide indicates an active or recently active fire in the sealed fire area. Again, when the fire goes out, the carbon monoxide will not be there. It will break back down into oxygen and carbon. And again, I don't totally understand that real well, but when the fire goes out, you will no longer have carbon monoxide. Question 27, what should be totally absent from air samples before an attempt is made to unseal a mine fire? And the answer to that is carbon monoxide. Again, if you sample the area behind the seals and you have levels of carbon monoxide, that means you have a fire. When the fire goes out, you will no longer have carbon monoxide. Question 28, when oxygen is reduced to this amount in a methane air mixture, an explosion is impossible. And the answer to that is 12%. We've already had that question once. Again, when oxygen is 12% or less, methane gas will not explode. Question 29, what amount of time should elapse after carbon monoxide has disappeared and the oxygen content is reduced to 1% before fire seals are opened? And the answer is a period of 100 days. And this will allow sufficient time for the area to cool to minimize the danger of rekindling. So after we think the fire's out, after there's no carbon monoxide and the oxygen has been reduced to 1%, and maybe we've took nitrogen to inert that area to 1% oxygen or less, we're still going to wait 100 days before we open those seals so it doesn't rekindle. And someone told me that's on the test, and they do ask for the period of time, so you need to remember that 100 days. Question 30, what should oxygen be reduced to before it is advisable to attempt to open a fire seal? And that is 1%. 31, what should be done prior to unsealing a mine fire? And the answer is preparation should be made for the fire gases to pass directly into the main return, and all entries out by the seals should be heavily rock dusted prior to unsealing a mine fire. So when we want to breach those seals, the air that comes out of those should be directed into the main return and the area heavily rock dusted. And you would have to have a permit and approval to do that. That would be a very strict guidelines to follow to breach those seals. Question 32, what is the comparative effect upon oxygen between a raging fire and a smoldering fire? And the answer is oxygen will be reduced faster in the presence of a raging fire. So the bigger the fire is, the more intense it is, the quicker it will consume the oxygen. Question 33, how will high volatile coal and an oily shale roof affect reopening a fire seal when other conditions indicate the seals could be removed safely? And the answer is heat will be retained longer and the danger of rekindling will be increased when the mine has an oily shale roof and high volatile coal. Question 34, what effect will variations of barometric pressure have on fire seals? So the barometric pressure is the atmospheric pressure, and the answer is variations of pressure will result in air leakage around the fire seals in the direction of lower pressure. So we know from our studies, previous studies, that air flows from high pressure to low pressure. So the seal is the yellow line here, and wherever the high pressure side of the seals is, it will leak that direction. So you may have fire seals that will outgas one day, and maybe in gas the next based on barometric pressure. And just keep in mind that air always flows from high pressure to low pressure. Question 35, what are the principal causes of mine explosions? And the answer is that ignition of gas or coal dust, or both, by electric arcs, blown out shots, and smoking. And a blown out shot would be when we would detonate explosives in a coal mine and didn't use proper stemming material, and the shot, the force of the explosion would just blow back out the hole and suspend coal dust. What's the most prevalent source in which mine explosions are started? And the answer to that, accumulations of explosive mixtures of methane. So almost any mine explosion that we have now would be a methane gas explosion. You could have coal dust explosion, but I think we could say that nearly 100% of mine explosions would be methane gas. Question 37, what's the principal cause of accumulations of explosive mixtures of methane? And the answer is that interrupted ventilation. So we have a very good ventilation plan at our mine, and we hang curtains and we build stoppings and we make the air flow where we want it to, and it dilutes the methane gas, and we do a very good job of that. And that system works almost always, but sometimes that can get interrupted. A curtain could get tore down, a stopping could get crushed out, something like that, and the ventilation system gets interrupted, could cause methane gas to build up. Question 38, what's the principal cause of interrupted ventilation? And the answer to that is short-circuiting the ventilating current, for example, by leaving doors open, tearing line curtain down, knocking out stoppings. These are the most common causes of interrupted ventilation. Question 39, principal cause of ignition of explosive mixtures. And the answer to that is electrical arcs. Question 40, who shall be notified immediately in the event of a mine explosion? And the answer to that is the director of the West Virginia Office of Miners Health Safety and Training and the district mine inspector. And we know immediate notification is within 15 minutes. 41, in the event of a mine explosion, how many persons should be placed in charge of recovery work? And it's only one. And that's probably going to be someone from Mine Safety and Health Administration or the West Virginia Office of Miners Health Safety and Training. Question 42, how many apparatus crews should be employed underground in recovery work after a mine explosion? And the answer to that is at least 2. So this is mine rescue teams. We want at least 2 mine rescue teams at the mine, or in the mine, after an explosion. So what we do, if we do have a mine explosion, is we start from the portal and we go 1,000 feet and make sure that 1,000 feet is safe. And then you can see my pointer here. At this point, we will establish a fresh air base. So there'll be one mine rescue team at the fresh air base, and there'll be another team under apparatus exploring ahead for another 1,000 feet. And after we determine that 1,000 feet is safe, we would move the fresh air base to the new point, and then another team would explore 1,000 feet ahead, and that's how we go into a mine, 1,000 feet at a time. So we always want 2 teams underground. We want one at the fresh air base, one exploring ahead. And also for every team that you have underground, you need a team on the surface. So I think anytime that you would be using mine rescue teams to try to get a fire put out or recover people that were in the mine, you would need 4 rescue teams, 2 underground, 2 on the surface. 43, persons on oxygen breathing apparatus crew should be, and this is mine rescue team members, and that's well trained, physically fit, and competent. So, it's a pretty big deal being a member of a mine rescue team, well trained. They have to have, I believe, 32 hours of initial training, and I think they have 96 hours of training every year. physically fit. They have to have a physical every year. They're carrying this mine rescue apparatus as a backpack, which is pretty heavy. They're going to be working in a mine in undesirable conditions, and certainly competent and skilled in knowing what to do. So we're very fortunate to have people that wants to be on mine rescue teams, and they've helped a lot of people. Question 44, what ventilation instrument should be provided for recovery work? And it's an anemometer. Question 45, before proceeding to a mine after an explosion, what area can be examined to determine what is going on in the mine? And the answer is the return airway should be examined for smoke and other indication of fire. So if you don't know what's going on in the mine, the best way to find out, or one thing that you can get some information from, is what's coming out of the mine. So you could, see if there's smoke, the indication of a fire. You could do gas tests. Is there levels of carbon monoxide? Is there levels of methane? So you can learn a lot about what's going on in the mine by seeing what's coming out of the mine. Question 46, how far apart should members of mine rescue team travel? And it's about 7 feet. Question 47, what's the length of a standard mine rescue lifeline? And the answer to that is 1,000 feet. And this is the maximum distance mine rescue team should explore under favorable conditions when lives are at stake. So we want a 1,000-foot rescue lifeline, and mine rescue teams now have wireless communication, but I think when they're in smoke, they would be attached to this lifeline, and it would be attached to the fresh air base. So if they did get disoriented of where they were at, they could follow that lifeline back to the fresh air base. So we have some mine rescue lifeline signals, and if you remember sardine, and what's important is the SARD. So remember the term sardine, and we'll explain this as we go here. So the first letter in sardine is S. So the first letter is equal to S is equal to stop. The second letter in sardine is A. So the second is equal to A, which is equal to advance. The third letter in sardine is R. So 3 is equal to R, which is equal to retreat. And the fourth letter in sardine is D, and 4 is equal to D, it's equal to distress. So hopefully this will make sense as we go through these questions. So question 48, what's a recommended lifeline signal to stop if traveling, or all right if at rest? And that's 1 pull. So 1 pull on the lifeline would indicate for you to stop. 49, recommend lifeline signal for advance, and that is 2 pulls. 50, recommend lifeline signal to retreat is 3 pulls. And 51, recommend lifeline signal for distress is 4 pulls. So remember, stop, advance, retreat, and distress. 52, in what condition of temperature is it high? Is it advisable to explore beyond fresh air? And that's when the temperature is high. So when the temperature is high, it is inadvisable to explore beyond fresh air. 53, what's the most harmful gas in afterdamp? And afterdamp is after a fire or an explosion. So the most harmful gas in the mine after a fire or explosion is carbon monoxide. 54, to prevent the gases of explosions from reaching the point where a barricade is erected, the air can be short-circuited at what distance? And the answer is at least 50 feet out by the place and erecting a temporary curtain. So if we had to build a barricade, and it's highly unlikely, but we'd build a barricade now because we have our rescue chambers. But if we was trying to make us a safe place to be, to not get into harmful air, we could make us, we could hang curtains or whatever to protect ourselves. But what we could do is go at least 50 feet out by and trying to divert that air from us. 55, how should a person conduct himself within a barricade? And the answer, remain quiet, occasionally moving about to mix the air. 56, how much air does the average person require per hour within a barricade? And the answer is the average person at rest requires about 1 cubic yard of air per hour within a barricaded area. So a cubic yard is a block of air that was 3 feet by 3 feet by 3 feet. Question 57, for what approximate length of time can 5 men be barricaded in an area that's 100 feet long, 10 feet wide, and 5 feet high before they begin to suffer from oxygen depletion? And the answer to that is 37 hours. So the test question is the same area, but has 10 men in the barricaded area. So the answer is 18.5 hours, and the correct choice on the test is 18 hours. So remember this question. If you see a question that asks how long 10 men can be in a barricaded area, the answer is going to be 18 hours. The math for that is you calculate the area, 100 feet in length, 10 feet wide by 5 feet high is 5,000 cubic feet. That's the area. We have 5,000 cubic feet. Converting cubic feet to cubic yards is 5,000 cubic feet divided by 27 cubic feet per cubic yard. That gives us 185.2 cubic yards of air. One man uses 1 cubic yard per hour, so 5 men could survive 4, and that's 185.2 cubic yards divided by 5 men is equal to 37 hours. Okay, the test question is for 10 men, so 185.2 cubic yards divided by 10 men is equal to 18.52 hours. And the test question is 18 hours. Now this would be difficult. You just need to remember that. Even if you know how to do the math, this would be a fairly difficult math problem because you're not allowed to use a calculator on the test. So just remember, if they want to know how long people can survive in a barricade, the answer, I think, on the test will be 18 hours. That's the end of this video. Thank you.